Hello students, welcome back. So far we have been discussing limits. Please recall that we took three approaches. First, a graphical approach. Second, the limit rule approach. And number three, the computational approach, or practical approach, whatever you may want to call. Now, let's change the topic just a little bit. Let's begin discussing continuity. Especially, we are interested in the continuity of piecewise defined functions. So what if we have an expression like this? Well, that's continuous. It's a polynomial. Trig function, again continuous. Another polynomial, that too is continuous. But if I patch those together, we may have some breaking behavior. Where can I have those breaking behavior? At exactly two possible places. X equal to 0, when we have this breaking, first line and second line, or x equals to pi, second line and third line. These two numbers may divide the number line in three pieces. First interval, second interval, and third interval. And each interval, we must have continuity because all these are well-defined nice functions. Polynomial, trig, they're all continuous. Possible bad point at x equal to 0 and x equals to pi. So how do we check? Well, we have to check these. F of 0 and the limit as x approaching to 0. So, where is it? Yeah. Oh, excuse me. Okay, all right. Left-hand side limit. And then the right-hand side limit. Come on. That's a question. Are these three all the same? Now, the left-hand side limit and right-hand side limit, those are really cumbersome to write like this. So let me abbreviate like this. F of 0 is a function value. Let me write it as 0 minus. Oops. It's just a shorthand of this. And then 0 plus, like that. Just a shorthand of this. So we are going to find these three, and if they're the same, then we have continuity. If any one of them is different, then we have discontinuity. And we have to do the same thing at pi. So here we go. F of pi, f of pi minus, f of pi plus. Again, please remember pi minus, that's just a left-hand side limit. Pi plus, that's the right-hand side limit. Just a shorthand, okay? Now, how do I find f of 0? Well, first line or second line? There's no chance we have third line, so we have either this or that. F of 0 is the first line because we have semi-inequality there. All right? So here, f of 0 is 0 squared minus 2 times 0. So that's 0. F of 0 minus, well, it's a little bit less than 0, so always the first line. So these two are the same. They're same because semi-inequalities are here in the first line. Okay, if the semi-inequality is down here, and this is strict inequality, and f of 0 will move to the next. All right, I have to use the second line, so sine of 0, oh, that's 0. So what do we have? They were the same. So we have to have continuity here, this and that. Can you check the same thing with this one or that one? F of pi, let's put pi minus. It'll be less than pi, so it's the second line, right? So sine of pi, and that's 0. Pi plus, how about that? I'll be greater than pi, so it has to go to the second line. That's -3 pi plus 2, and that's not 0. That's heck of less than 0. -3 times 3 times 1/4 something, so greater than -9 plus 2, that's less than 0. So these two are different. And as for f of pi, where does it go? Does it go to the second line or third line? Where's the semi-inequality? It's in the second line, so it should be f of pi belong here. Now, if you forget about this, and then just do these two computations, f of pi minus, f of pi plus, and then get your conclusion, discontinuity here. And if you forget about this, and then compare only these two, 0, 0, so we have continuity, nobody will take off any point. This one is where we have this f of 0 and f of pi is not that important. Unless, of course, we have a separate line so that f of 0 is -14, specifically defined like that, then that's different. But the usual problems, you don't really have to worry about these. Usually. Still, you should know how to put it. For example, if semi-inequality is moved here, and then this had been strict, then I have to move this. I have to move this to over here. F of pi is equal to f of pi plus. Well, let's go back to the original. This is semi-inequality, so, and then this is strict. This is semi, okay, all right. And here is the graphical justification. We have continuity here, but we have discontinuity. And the solution, yep, plug in x equals to pi, x equals to 0, and x equals to pi. They're all the same, continuity. They're all different. And these two are the same, but this one is different. Not all the same, so we have discontinuity. How about the next example here? Well, I'll give you some time to work on. Stop the playback and get those x values. Let's see, what did you get? X equals to -1 and x equals to pi. There are two possible breaking points. Do you see those? -1 here and there, pi here and there. So plugging -1 to first line, we get candidate 1. Plugging -1 to the second you get candidate 2. Are they the same? Plug in pi to the second line, plug in pi to the third line, we get these two candidates. Are they the same? Here's a visualization. It turns out they're all different each time. So we don't have continuity anywhere. So x equal to -1, discontinuity. X equals to pi, we have discontinuity. Of course, other than those, we have to have continuity, of course. We have those two discontinuities. At x equal to -1, plug into the first line, plug into the second line. They're not the same, so we have discontinuity. Plug in pi to the second line, to the third line. They're not the same, so no, we have discontinuity again. So whenever you have piecewise defined function, checking for continuity versus discontinuity should be easy. Just find out possible breaking points, plug those in. Okay, we went through some examples, but it's not that these examples are really important. Why did I go through with those anyway? That's because these examples serve as a stepping stone towards something more important. I'll show you what are important classes. They're right here. Similarly, we have piecewise defined function, and then just like the previous problem, you gotta know where the possible breaking points are. X equals to what and x equals to what. Do you see those? And then when are they continuous? Something is equal to something. Something else is equal to something else, kind of like those. And then we have some unknown parameters here, a and b. So we have two equations and two unknown parameters. Can we solve it? That's basically what this problem is all about. So, using what we discussed in the previous problems as stepping stone, work through this. So what did you do? Plug in 0 to first line, second line, plug in pi to second line, third line, and check whether they are the same. Here, plug in -1, plug in -1, see if those are the same. Plug in pi, see if those are the same. Likewise here, plug in x equal to something, and then see one is equal to the other, and then do the same thing at another point, so that we have two equations and two unknown parameters. Good luck. Let's talk about this in the next video. Until then, try on your own.